In January 2005, NASA launched a unique probe into space. Its mission was to uncover the origins of water on Earth. Named Deep Impact, this probe traveled 270 million kilometers before reaching a comet. This comet held many secrets that had been sought after for centuries. Viewers, in the entire universe, there is only one place where human beings can survive: Earth. It seems as if Earth was created specifically for humans. It has everything necessary for life: water, food, and oxygen. In this vast and giant universe, whether another planet like Earth exists or not remains unknown. But for now, Earth is the only planet we know where humans can live without external aid. However, 5 billion years ago, Earth did not exist. The place where our Earth and solar system exist today is the edge of the Milky Way galaxy. Before Earth was formed, a massive cloud of dust and gases floated in space. Eventually, something happened in this cloud that led to the formation of a planet, the very planet we live on today. This cloud of dust and gases is called a molecular cloud. It contained dust particles, including sand, silicon, and metal grains. This cloud originated from the remains of dead stars. In the early universe, stars that had burned all their fuel exploded, scattering their elements into space. Unlike the familiar clouds in the sky, these molecular clouds appear differently and have been captured using the Hubble Space Telescope. Surprisingly, these clouds can be 100 light-years wide, meaning that if light starts traveling from one end, it will take 100 years to reach the other. To put it into perspective, this cloud was 6 million times larger than the distance between Earth and the Sun. These clouds are responsible for the birth of new stars and planets, and the force that drives this process is gravity. Yes, the same gravity that governs space, except in this case, it is generated within the cloud itself. Objects with larger mass exert a stronger gravitational pull, attracting smaller objects toward them. The particles in the molecular cloud began clumping together due to gravity. Larger particles attracted smaller ones, causing frequent collisions. These collisions generated energy, heating up the center of the spinning cloud. Over millions of years, this process continued. The core grew larger, spun faster, and became hotter. Eventually, this giant ball of fire became our sun. The remaining molecular clouds started orbiting the sun. From these leftover particles and gases, the planets, moons, and other celestial bodies of our solar system were formed. But how did this happen? This was once a mystery, but not anymore. The idea that stars form from molecular clouds was first proposed in the 1700s by German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace. However, at the time, it was merely a hypothesis. Between the 1920s and 1950s, as telescopes advanced, astronomers observed dust storms in space, inside which new stars were forming. However, these clouds were too thick to be seen through normal telescopes. Then, in the 1970s and 1980s, the invention of radio and infrared telescopes solved this problem. Now, scientists could see through these dense clouds. Using infrared telescopes, astronomers witnessed new planets forming inside molecular clouds. This confirmed that new stars are born within these clouds, and the leftover particles from these stars eventually form planets. In March 2003, aboard the International Space Station, an experiment was conducted that finally answered a question that had puzzled scientists for centuries. NASA astronaut Don Pettit was testing how different substances behave in space. He created water bubbles, dissolved effervescent tablets, and even spun a plastic bag filled with salt. The purpose of these experiments was different, but one of them unexpectedly revealed the answer to a mystery as old as time itself. When Pettit placed salt in a plastic bag and spun it, the tiny salt particles began sticking together. Why? Because in space, objects naturally attract each other. Scientists now believe that this same process happened in molecular clouds, where tiny dust and gas particles slowly clump together, eventually forming planets. Around 4.5 billion years ago, molecular clouds began merging, just like the salt grains in Don Pettit's experiment. As these clusters grew larger, they gained stronger gravity. Once a clump reached 1 kilometer in size, about as big as a mountain, it had enough gravitational pull to attract even more particles. Just like a vacuum cleaner sucking in dust, this process continued for millions of years. Eventually, these growing clusters of matter formed around 20 protoplanets, all orbiting the newly born sun. But there was a problem. These early planets began colliding with each other. Each collision combined 2 planets into one. After countless impacts, the number of planets decreased, leaving behind just a few survivors, including Mercury, Venus, Mars, and our Earth. But Earth didn't look like the blue and green planet we know today. It was a burning sphere of molten rock, formed from violent planetary collisions. At this stage, Earth's temperature was around 5,000 degrees Celsius, hot enough to vaporize anything in seconds. Life couldn't exist yet, but even if Earth cooled down, it still had to survive the most dangerous threat of all: solar storms. Powerful solar radiation has stripped away the atmospheres of many planets, including Mars, which could have once supported life. So how did Earth survive? The answer lies deep within Earth's core. During its formation, heavy metals like iron and nickel sank towards the center of the planet. Scientists have discovered that when molten iron spins, it generates a magnetic field. This process created Earth's magnetosphere, a massive invisible shield that extends 370,000 kilometers into space on the sun-facing side. On the dark side of Earth, it stretches even farther, protecting us from deadly solar winds. Thanks to this magnetic shield, Earth remained safe, allowing life to eventually emerge and thrive. But this shield isn't perfect. At the North and South poles, solar particles still enter the atmosphere, but it does not make any harm, creating one of the most breathtaking sights in nature, the aurora borealis and aurora australis. These stunning lights remind us of a crucial fact. Earth's survival in the violent universe was never guaranteed. The young Earth had survived deadly solar storms, but it still wasn't ready for life. Another catastrophic event was about to reshape it forever: a planetary collision. How do we even know this happened? To find the answer, we need to go back to the 1960s. During NASA's Apollo missions, astronauts collected rock samples from the moon. At first, scientists believed the moon was just a piece of Earth that broke away. But when they examined these moon rocks, something shocking was discovered. Unlike Earth's rocks, the moon's surface appeared burned and altered by extreme heat. Further research revealed that the oxygen isotopes in moon and Earth rocks were identical. This meant that the moon was indeed a part of Earth, but something had melted and reshaped it entirely. And there was only one possible explanation: a massive planetary impact. When Earth was still cooling down, another planet, Theia, began drifting dangerously close. It was almost the size of Mars, and it was on a collision course with Earth. Then, the inevitable happened. When Theia crashed into Earth, the impact released more energy than 1 billion nuclear bombs. Both planets shattered into countless fragments, and the debris spread into space. Over millions of years, these floating rock particles slowly clumped together, eventually forming what we now call the Moon. But this collision didn't just create the Moon. It also tilted Earth on its axis to exactly 23.5 degrees. This tilt became one of the most important factors for life on Earth. The 23.5-degree tilt of Earth is what gives us seasons. When the northern hemisphere is tilted toward the sun, it experiences summer, and when it tilts away, it enters winter. Without this tilt, Earth wouldn't have diverse climates, seasonal changes, or even food cycles. The tilt also created the monsoon cycle, allowing fresh water to flow through rivers. And thanks to the moon's gravitational pull, ocean tides formed, creating a system that distributes nutrients for marine life. But wait, how could ocean tides exist before Earth even had water? Where did Earth's water come from? This was one of science's biggest mysteries. Until NASA launched a groundbreaking mission in 2005. In January 2005, NASA launched the Deep Impact Probe. Its mission? To travel 270 million kilometers and collide with a comet named Tempel 1. On July 4, 2005, a copper impactor slammed into the comet at 38,000 kilometers per hour. The explosion sent a huge cloud of material into space. And when scientists analyzed the light using spectroscopy, they made a shocking discovery. The comet was full of frozen water. This proved that water exists deep inside comets. But if water was trapped inside comets, how did it reach Earth? Scientists believe that billions of years ago, these icy comets were knocked off course toward Earth. But who sent them? The answer is Jupiter, the largest planet in our solar system. Jupiter's massive gravity pulls on nearby objects, disturbing the orbits of asteroids and comets. Originally, comets had a circular orbit around the Sun, but Jupiter's gravity stretched their paths, turning them into elliptical orbits, bringing them closer to Earth. Over millions of years, these comets bombarded Earth, delivering vast amounts of water. But how do we know that Earth's water came from space? The answer lies in a special mineral, zircon. Zircon crystals only form in the presence of liquid water. And the oldest zircon samples on Earth are 4 billion years old, proving that water arrived 500 million years after Earth's formation. This means that without Jupiter's influence, Earth might have never received water, and life as we know it wouldn't exist. Let's look at the incredible series of events that made life on Earth possible. A molecular cloud formed our solar system. The Theia collision created the Moon and tilted Earth's axis. The tilt gave Earth seasons, monsoons, and a stable climate. Jupiter's gravity redirected water-filled comets toward Earth. Water finally arrived, paving the way for life to begin. Earth had cooled down, and the first signs of life were beginning to emerge. But something crucial was still missing: oxygen. Without oxygen, complex life couldn't evolve. So where did Earth's oxygen come from? Tell me in the comments below what you think. And don't forget to like, share, and subscribe for more mind-blowing space discoveries. Hit the bell icon so you never miss an amazing video.